For the following exercises, use the graph of the one-to-one function shown in figure 12. So the first thing is we got to sketch the graph of the inverse function. Okay? Now remember, all the inverse function means is that we're going to switch the x's and the y's. In other words, if you had something that looked like this, then the inverse, whoa, wait a minute. Then the inverse function will look basically like this. That the y goes in there and the x is on the other side now. We're switching the x's and the y's. In other words, to make this practical, pretend that we have these two. Well, don't pretend. I mean, we got those. We got these two statements here. That means whatever my x and my y value is here, okay, we'll basically switch positions. Okay, this will then be the y, and this will be the x. Now, you might be saying, well, wait a minute, you know, anytime I've seen ordered pairs, I always know x comes first and now y is second, so what the heck are you saying here? The x value will still come first. However, what I'm trying to do is I'm trying to take the y value of the original function and note to you that it will become the x value of the inverse function. That's how I'm trying to show this. Okay? So maybe a better way might be to do it like this, possibly. If the blue represents the y value of the original function, then that same blue value will represent the x value of the inverse function. Okay? And consequently then, the red x of the original will represent then the y value of the inverse. Okay? It does not matter how you view it. When we deal with numbers now, I know this might be confusing, but watch how easy it is. So what's the coordinate of this point? It's 2, 0, right? 2, 0. So if this is the coordinate of the normal function f, it doesn't have a -1, so that's why it's not the inverse. But if I want to now find the coordinates of the inverse, guess what I got to do? I literally just go like this. 0, 2. Okay? Now this is not really proper notation here. I'm just trying to show you that the inverse function, the coordinates would basically switch. Okay? Right? So the coordinates now of the inverse function of this point will be 0, 2. So 0's here, 2 is then going to be up here. So boom, here's the new point. Okay? Now watch, let's do the next point. Okay? Let's pick this one out. Let's say this one is pretty close to about, it looks like it's close to about 6, 2 to me, right? 6, 2. So if that's the coordinate of the original function, then what's the coordinate of the inverse? Switcherooski. Well, it becomes now 2, 6 of the inverse. So plot that. You go to 2, and then you go up 6. So the coordinate here will be right there. So that's that. Let's do one more, okay? And then I think you're going to see a pattern. All right, so what are the coordinates of this particular point right here? Well, it simply has a value of x is equal to 10, and then we got to go up 3 spots, right? So the value there is going to be 10, 3. Now, what do you think we're going to do, right? You're like, oh man, this is so simple now. We're just going to do a little switcherooski, right? 3, 10 then for the inverse function. So we got to go to 3, and then we got to go all the way up to 10. Okay, so it looks like the point will lie right about there. All right. Now what we need to do is simply connect the dots, okay? Now if you notice, this isn't exactly linear, because if I drew a straight line, you see how I'm kind of missing that little dot, the blue one? So it's got a little curve to it. Now, what do you think the pattern is here? What do you think the visual relationship between these two functions are? And I'll label this f minus 1. The visual relationship now between these two functions is that they are reflections in the line y is equal to x. That's the relationship. You see how they are basically mirror images, a reflection, so to speak, through this particular line. That's what an inverse function is. Now you can learn it that way. That's totally fine. But I think the easier way to apply the concept is much easier if you just think about switching some values around and then sketching it, and then maybe taking a step back and be like, oh, shoot. Damn, that was nice, right? So that's that. Okay, that's the graph. Now let's take a look at the next question. It says, find f of 6 and f minus 1 of 2. All right, so let's reinterpret this, all right? So it says find f of 6, okay? So remember, this is in the notation of f is equal to, f of x is equal to y. So they told you the x value, right? They told it to you. They said now that f, what happened? F of 6 is equal to something. So here's your x is equal to 6, and y is equal to something. So remember, you have to be looking at the original function though. So when x is 6, what is y equal to of the original function? You're like, oh, 2. Is that the answer? That's the answer. Okay, that's the answer for this. So when x is 6, when x is 6 for the original function, y has a value of 2. All right, cool. Now, what do we do in the second case? Now, there's a couple of ways you can look at this. All right. So what I'm going to do is let's assume you have the graph, the inverse function graph. Okay. Now, if you have that inverse function graph, what's going to happen is you're going to think about it purely like this. F inverse of x. This is if you have that inverse function graph. All right. This is the 2, and this is going to be equal to now question mark. Okay. This still has the same outline as what we did before. This still has the same actual outline of f minus 1 of x will be equal to y, assuming you know the graph, the inverse function. Okay? So go to your inverse function now. Find the value, find where x is 2. Boom. Okay, x is 2 right there. And then what's the y value? 6. So what's the answer to this? The answer is simply now going to be, for the inverse function when x is 2, y is equal to 6. That's the answer. Okay? Now that's nice. If you have the inverse function graph already graphed out, you just think about it like you normally would. Here's your x and here's your y. Okay? But let's say you didn't have that. All right? And now the only thing you had was you knew this to be true. Okay? So watch what's going to happen. So when you have this, f of x is equal to y, the inverse function will basically switch, like we said before, the x and the y values. Okay? But remember, this still represents technically x. So what I'm trying to say is that if this is a blue y, then that blue y will now become an x value, okay, of the second equation. And if this is my red x, then that becomes the red y, all right, of the second inverse, equation, or the inverse equation. So now notice that when you do this, if your original here was, as we found, f of 6 is 2, then that must mean now, that the inverse function now, remember, just switch whatever this y value was becomes the new x. So that means this 2 becomes the new value in there. And wait a minute, that looks pretty identical to what we have here. And then that must mean that whatever was inside now of this part, the x, now became the new y, and that's equal to 6. And wait a minute, that's exactly what we found before. Okay? So a couple of ways to analyze it. Moving on. If the complete graph of f is shown, find the domain. Remember, the domain is just, not to use this word, but it's the range, right, of x values. It's the limit of the x values, basically. All right, the minimum x value that this original function has, they're talking about the original, and all the way to the maximum x function. So it looks like to me, with my eyes, that it starts at x is equal to 2 and it ends at x is equal to 10, right? So the domain is 2 to 10, okay? So you can write that in a couple of ways. It depends on the notation that they want. You can write it 2 less than or equal to x less than or equal to 10, something along those lines, okay? You can also use the bracket notation. Inclusive, you have to use the bracket, not the parenthesis, because it does include 2 and 10, so that's fine too, a whole bunch of ways. Now it says if the complete graph of f is shown. Let's do the second equation, find the range. So the range now is just the range of y values. I shouldn't really say it that way, but you know what I mean. Okay, it's the limit of the y values, the most minimum y all the way to the most maximum y. So it looks like to me that it's going to start at y is equal to 0, and it's going to end at y is basically equal to 3, right? I'll try to draw that a little better, okay? So that's the range, 0 to 3, right? That's all. So you can write it this way if you wanted, 0 less than, y less than equal to 3. I mean, there's a whole bunch of ways to do it, okay? You can also use bracket notation, whole bunch, all right? So guys, thanks for tuning in, appreciate it. I really do hope this helped, and if it did, give us a hand. Hit the like button, subscribe. Check out some of our other videos. We got a whole bunch to try to help you through your course, and yeah, I look forward to helping you with more problems. Take care.